The last thing we want to look at in this lesson deals with transformation of the functions, logarithmic functions, that is. And very similar to everything we've been doing in the past, let's go ahead and look at what f of x equals log of x would look like. So we have a log x. Go ahead and graph that. So that's what we have, kind of a curve that goes like that. Let's zoom in. Let's actually try zoom fit so you can get a better look at it. And just like our functions before, we have to kind of consider what the inside of the function and what the outside of the function is. So if you have log of x plus 1, this is going to do the opposite of what you'd expect. So since it's plus 1, it's going to move over to the left. If we had something like log of x, and we added 1 to this whole thing, that's where you would see movement upward. So let's go ahead and see that on the graph. If we go ahead and also graph log of x plus 1, you'll see when we go back to the graph, that's been shifted over 1 to the left, but the identical same graph. So let's look at this next example. F of x equals log x again, and now we've got this shift involving m of x, and we're going to have negative log x minus 2. Notice the minus 2 is not in parentheses, so that minus 2 should shift that function 2 downward, and this negative should reflect it over the x-axis. So let's go ahead and bring that up. So we have y equals now negative log x. I'm going to go ahead and put that x in parentheses and then subtract the 2 afterwards just to make sure our graph is clear. Let's go ahead and graph it. I'm actually going to try to zoom fit this here to make sure it all gets on the screen. So I'll pick 0. So there's our original f of x and our m of x, which is down 2 and flipped over the x-axis. Finally, let's look at this last example. Notice we're dealing with something like 5 log of x for n of x. And since this 5 is on the outside, it's going to expand it vertically. However, realize if we had something like log 5 of x, that would cause a horizontal contraction. Remember, it's the opposite when it's on the inside. So not only will that expand it vertically, but also we're going to see movement 3 to the right. Since that's on the inside, negatives are going to move our graph to the right. So let's just verify that once again with our graphing calculator. So we go and change this to 5 log of x. This time the minus 3 is inside the parentheses. So let's zoom and fit this. So there's our original f of x, and you can see n of x has been stretched clearly in the vertical direction and also moved to the right 3 units. So one last one for you to try on your own. This time we're looking at the graph of ln of x, which you'll see in blue there, and you want to figure out how it would transform if we had p of x that equaled ln of x minus 2 plus 1.